right, so we're going to use some problems from the 2-4C at-home practice problems from the book. 2-4C at-home practice problems. Basically, we are solving a system of linear equations, and all of these are using the elimination method. Now, we're not going to go through every single one of these, but I will go through a few, and you'll see the pattern as we do this. So, let's start with number 1 here. 2x minus y equals 5, and 3x plus y equals 10. Now, obviously, I want to find an x and a y value so that when you plug it in to the first equation, it gives you a true statement. And when you plug it into the second equation, it also gives you a true statement. So what I'm going to do here is take a look at the coefficients of the variables. Well, let me take a step back real quick and just say, note that the x's, the y's, the equal signs, and these constants here are all aligned. So since they're all aligned, I can do the elimination method right now. So step 1, they're all aligned. Step 2, take a look at the coefficients of the variables. Now the variables x has coefficients of 2 and 3. Those are obviously not opposite numbers. One is not the negative of the other. But if you look at the coefficients of y, one of these coefficients is -1, and the other is +1. So -1 and +1 are opposites. They're going to add up and give you 0. And so that's a very good thing. That's what we want. All right. So what we do, since the coefficients are opposite, all I have to do is take these two equations and add them up. Everything's lined up. 2x plus 3x will be 5x. And then -y plus y is going to be 0y. 5, 10 is going to add up to 15. All right, so I'm adding these things up. I'm getting a 5x plus 0y equals 15. Now, because 0y is just 0, I don't have to include that, and I get 5x equals 15. Now, because I started with opposite coefficients, that eliminated the variable y, thus the name elimination method. And so now I can just solve this equation for x. And the way we do that is we divide by 5. So dividing by 5 would give me x is equal to 3. Now, if x is equal to 3, then I say, well, let's plug in x equal to 3 into an equation. Specifically, one of these two that I started with. Doesn't matter which one. I'm going to plug it in to this second equation, just because that way I'm going to have less steps. I know that. So we're going to plug it into, let's say, the equation 3x plus y equals 10. So what we're going to do is we're going to go 3 times 3 plus y, set that equal to 10. 3 times 3 is 9. So what you get is 9 plus y equals 10. In order to get y by itself, we just subtract 9 from both sides. When you subtract when you subtract 9 from both sides, you get y equals 1. So there you go. We use the elimination to add these two equations together. Because they had opposite coefficients, we got x equals 3, and then when we plug that back into the equation here, we ended up with y equals 1. That means that the solution to this system of two linear equations is the point 3, 1. Again, sometimes this is called the elimination method, sometimes called addition method because we're adding the two equations up. So there you go. That's the solution. The solution is the point 3, 1. And you can check that if you'd like to by plugging in 3, 1 into this first equation and 3, 1 into this second equation and see that you get true statements each time. This problem says 3x plus 2y equals 13, 4x minus y equals 10. Those are our two lines, and so we're going to use the elimination method in order to solve those. Now, 3x plus 2y equals 13, 4x minus y equals 10. Let's go to the worksheet here. Now, first step, things are lined up. The x's are lined up, the y's are lined up, the equal signs are lined up, the constant numbers are lined up. So everything's lined up. That's a good thing for the elimination method. However, we don't have opposite numbers on coefficients of the x. Notice coefficients of the x are 3 and 4. If you add those up, you get 7. That doesn't eliminate. And you look at coefficients of 2 and negative 1 on the y. If you add those up, those don't eliminate either. So what we're going to do is we're going to force opposite coefficients. So what we do is we take this set, this pair of equations, this system of equations, and we're going to have to multiply the top by a number and the top equation by a number, the bottom equation by a number, in order to get opposite coefficients. Now, the number we're going to pick depends on whether I want to eliminate the y's or eliminate the x's. I'm going to go ahead and eliminate the y's this time. And so what I do is I highlight the coefficient of y in the first equation. It's a 2. So let me actually just go ahead and highlight that 2. And then I highlight the coefficient of y in the second equation. It's actually a negative 1, although there's not a 1 actually there. So what I do is I take my first equation and I take my second equation and I'm going to multiply every term by these coefficients. So I'm going to take the 2 here. Now notice that this is a positive 2. That's going to be important. And I'm going to take that positive 2 and multiply it by the second equation. I'm going to take this negative 1 and I'm going to multiply that negative 1 times the top equation. Now, we're going to change this slightly. Remember, all we're going to do is, since one of these is negative and one of these is positive, I'm going to eliminate the negative sign. What that does is when I multiply, it's going to make one of my coefficients of y be positive and one of my coefficients of y be negative. If you multiply that through, all right, if you multiply that through, 1 times 3x is 3x, 1 times 2y is 2y, 1 times 13 is 13. By the way, there's many people who would rather, I'm sure, write this as multiplying a 1 on to both sides of the equation. I shorthand that and I just say multiply times 1 times the equation. It means both on the left-hand side and on the right. Same thing here. When I multiply 2, I'm going to multiply times the left-hand side of the equation and the right. So 1 times 3x is 3x, 1 times 2y is 2y, 1 times 13 is 13. So that first equation is not going to change. The second equation, 2 times 4x becomes 8x. 2 times negative 1y becomes negative 2y. 2 times 10 becomes 20. Now I'm left with a system of equations where the coefficients of y are opposite numbers, meaning that when I add them up, you're going to get 0 y's. So now I can add the two equations up. So I take these two equations, I add them up. What we're going to end up with is 11x is equal to 33. If you divide both sides by 11, you end up with x is equal to 3. So what we're going to do, now that I've found my x value, we're going to plug in x into one of these two equations. Now, I'm going to plug them into one of the two original equations. Doesn't matter which one. I guess I'll just do the first one here. 3x plus 2y equals 13. If I plug in 3 into the x value there, whoops, we end up with 9 plus 2y equals 13. Subtract 9 from both sides, you end up with 2y equals 4. Divide by 2 on both sides, you get y is equal to 2. So therefore, we know that x has to be 3, y has to be 2. So the point that these two lines have in common is the point 3, 2. So that you can always check by plugging in 3, 2 into the first equation and 3, 2 into the second equation and see that you get a true statement. So there you go. Solution is the point 3, 2. So if ever you don't have coefficients that are opposites, in other words, if ever we don't have coefficients where I add up the equations and one of the variables goes away, gets eliminated, then I can make it so by just taking the coefficient of, let's say, the y, multiplying that times the other equation, this coefficient times the other equation, change one of the signs, right? Always change one of the signs. All right, so that is how you do that second problem. Now, we can also do this third problem as well. We have x minus 2y equals 1, and 3x plus y equals 17. So let's go ahead and do that. Excuse me. All right, so here are our two equations. Let's go ahead and copy those down. So I want opposite coefficients. Now it doesn't matter which variable we eliminate. In the last problem that I did, I eliminated the variable y first. Let's eliminate the variable x this time, just to show you that it works the same regardless of what we do. So what I'm going to do is notice that the x's are not opposites. Okay, in fact, the first equation has coefficient of 1 on the x. The second equation has coefficient of 3. But let's highlight those. So what I do is I take the 1 and 3, and what I'm going to do is I'm going to swap those numbers. I'm going to take the 3 and I'm going to multiply it times the top equation, the 1 by the bottom equation, except I have to change one of the signs. I can either change this positive 3 to a negative 3, or I can change the positive 1 to a negative 1. Again, that's so that I get one negative value and one positive when I go ahead and multiply through. Negative value as the coefficient of my x, and positive value as the coefficient of my x. So I'm going to do the negative 3 and a positive 1. So negative 3 times 1x becomes negative 3x. Negative 3 times negative 2y becomes a plus 6y. Negative 3 times 1 becomes negative 3. Again, if you're in somebody else's class, you might put multiply on the left and multiply on the right separately. And then 1 times 3x is 3x. 1 times y is 1y, or just y, doesn't matter how you write that. 1 times 17 is just 17. Now we've done what we set out to accomplish. Now we've multiplied both equations, and now I have opposite numbers on the x's. Therefore, when I add those, what's going to happen is the x's will be eliminated. So add the equations. Negative 3x plus 3x is 0x. 6y plus 1y is 7y. Negative 3 plus 17 is 14. And therefore, divide both sides by 7 on that equation, you get y equals 2. So now we found y, that our y value has to be 2. By the way, you could have eliminated the y's and solved for x's as well. That's very similar to the approach I did last time. So now all we have to do is take one of our equations. I guess I'll take this first one here. And we need to plug in this case, y equals 2 into that equation. So what we're going to get is x minus 2 multiplied times 2 equals 1, which means that x minus 4 is 1. Add 4 to both sides, and you get x equals 5. So notice the x value in this case is 5, y value is 2. That means the solution is the point 5, comma 2. All right, make sure the x value comes first whenever you write a solution. And once again, if you wanted to check that, if you wanted to check that 5, 2 was a solution to this system of linear equations, you could plug it into this first equation, see that you get a true statement, and then plug it into the second equation and see that you get the true statement as well. All right. So the point 5, 2 is the single point that's shared by both lines. Solution to both lines, therefore solution to the system of linear equations. Now you can do the same thing for all of these other problems in the at-home practice problems. There are 3 more of them. If you'd like to try those, use the same format that I just did for problems 1, 2, and 3. And then you can also check your answers in the back of the book. So there you go. That's the elimination method in a nutshell.